In this section, we're going to explore a new idea called logarithms and understand the idea of the inverse function between a logarithm and an exponential function. We've just been graphing exponential functions in the last section or two, and today we're going to introduce the new idea, and that idea is called a logarithm. And a logarithm is merely a way to take an exponential function and write it reversing using the idea of an inverse of the x's and the y's. And so here I have the traditional y equals b to the x, and then I've rewritten this reversing the x's and the y's and inverting them, and this other part is read log of base b of y equals x. So log base b of y equals x. So what I want to show you how to do today is rewrite exponential form in logarithmic form. And we're going to practice writing this a number of times today, and after a little while it'll become very familiar and hopefully very comfortable for you. So we're going to rewrite our problem as y equals b to the x. And over here to the right, I'm going to write log base b of y equals x. And now what I want to do below it is I want to transform this 729 equals 3 to the 6 into our log function. So this is going to be the log of our base is 3 of 729 equals 6. It's a little bit different than what we've done before, but our goal is just to transform from exponential form into logarithmic form. Let's try that again. And each time we're going to do this, we're going to rewrite our equation. We're going to rewrite that basic log transformation formula. So y equals b to the x, and log base b of y equals x. So let's transform this one. The log of our base is 2, our y value is 32, and our x is 5. Okay, so we're just going to continue to keep trying these and practicing these as we go through. Here we go again. First our formula. Now you'll notice I put the 7 squared first. So we're just going to say b to the x equals y. We're still going to say log base b of y equals x. So let's transpose this. Log, our base this time is 7, our y value is 49, and that equals 2. Hope you're getting the hang of this. Let's try our next one. Once again, let's write our equation. B to the x equals y, where the log of base b of y equals x. So this is the log. Our base this time is 10. Our y value is 1, and this equals 0. Now this is a very rare case. This is called a common logarithm, and I need to kind of give you a little sidebar here. Sometimes we don't even write it when there's a base of 10. We would just write this as log of 1 equals 0. And right down here, you would have to understand there's an invisible 10 that is not written. So we've just kind of picked up on something we're going to talk about later, which is called a common log. Let's keep going in our practice here. All right, our next one, we have some fractions thrown in. Hopefully that's not too big a deal. But let's rewrite our problem again. B to the x equals y. So this is the log of base b of y equals x. So let's write this now as a logarithm. So we have the log of our base is 1/2 in parentheses of 1/8 equals 3. So here's just a number of examples of how to convert from an exponential equation into a logarithmic equation. In our next section, we're going to talk about how to convert from a logarithm back into an exponential equation and then maybe be able to solve it. So let's write once again our equation. So our basic equation is y equals b to the x, or the log of base b of x, of y equals x. So here we go. Here we have the log base b of y. So the log base 3 of 27. So we rewrite this as 3 to the x equals 27. So you may ask yourself, what cubed equals 27? Well, possibly you can just realize that that's x equals 3. Another way to approach it would be to write both problems with the same base. 3 to a power equals 3 cubed. So therefore the exponent must be equal if the base is equal. Let's look at our next one. The base is 9, so that's the b. So 9 raised to the x equals 81. So 9 to the x equals 9 squared, because that's 81. And if the bases are equal, then there's a rule that says the exponents must also be equal. So therefore we can say x equals 2. Let's look down at our next one. We have the base is 2. We're going to say this equals x. So raised to the x equals 16. Now we have to think 16 is 2 to the 4th. And since the bases are the same, that means the exponents are the same. And therefore my answer is x equals 4. Let's look at our last one in this section. Our base here is 25. So 25 raised to the x equals 5. Now for this is the first time that it's a little bit different, but I can write 25 as 5 squared. And that equals 5 to the first. So 5 to the 2x equals 5 to the first. That means that 2x equals 1 and x equals 1/2. And isn't the square root of 25 equal to 5? And an exponent of 1/2 is a square root. So that's just a couple ways to solve an exponential equation. So we've talked a little bit before, and I alluded to this on the first page, that there's a particular logarithm that has a specific base. And that particular logarithm is called a common logarithm. And it happens when no basis is shown and it's assumed to be a base 10. So in this next problem, we have log of 10. Well, that's assumed to be a base of 10. So you would say 10 to the what equals 10. Well, I hope it's obvious that x equals 1, therefore. So the log of 10 equals 1. All right, let's look at our next one. Log of 1,000. Remember, there's an invisible 10 there. So 10 to what power equals 1,000? 1,000 has 3 zeros, so 10 to the third equals 1,000. So our answer will be 3, because that's the value of x. Our third one is a mistype. I was supposed to have the log of 100. So we're really saying log base 10 of 100 equals what? Well, 10 to the what equals 100. Pretty straightforward. I think you would see that x equals 2. So my answer is 2. Let's look at our last one. Log base 10 of 100,000 equals x. So 10 to the x equals 100,000. If you're trying to think how to do that very quickly, 100,000 has 5 zeros, so that's 10 to the 5th. Therefore, x equals 5, and our simple answer is 5. So maybe you're realizing it when you're taking a common log of a number, this 10 or 100 or 1,000 or 100,000, the answer is the number of zeros that are in the log of the problem. So that's just kind of a quick introduction to logarithms. I think our most important formula for today comes way back to the top as we focus on this. If y equals b to the x, then the log base b of y equals x. So that's kind of our introduction to logarithms. I hope as we're going back and forth between logarithms and exponents, this will slowly become a little bit more comfortable for you as a new idea as the inverse of an exponential function. Our homework is going to be page 442, numbers 6 through 25 all, and I have put that on the next page for you to make it a little bit easier for you to kick this off.